Welcome to the DIY Honda Garage channel. This presentation addresses DTC P0235, which signals an issue with the turbocharger boost sensor. This error code indicates that the turbocharger boost sensor is out of range, which affects the engine's performance. The turbocharger boost sensor is located in the engine bay and is responsible for monitoring the pressure of the intake manifold to regulate the boost provided by the turbocharger. A malfunction here can lead to decreased power output and fuel efficiency problems. Understanding this issue is critical as it directly impacts the vehicle's overall driving dynamics and engine health. Let's explore how to diagnose and rectify this problem effectively. The turbocharger boost sensor plays a crucial role in the engine management system by providing data on the manifold pressure to the powertrain control module, PCM. This information enables optimal adjustment of the air-fuel mixture to enhance performance and efficiency. The sensor is typically situated near the turbocharger assembly in the engine compartment. When the reading from this sensor is out of its designated range, it can lead to inefficient combustion, which severely impacts engine performance. The PCM relies on accurate input from the boost sensor to manage boost pressure effectively. Therefore, any faults can indicate significant underlying issues requiring timely attention. Several factors can cause DTC P0235, starting with a faulty turbocharger boost sensor itself, which may not read the manifold pressure correctly. Additionally, wiring issues along the VCC2 line are often culprits, either through short circuits or disconnection, which disrupts the signal path between the sensor and the PCM. An open circuit can occur if the wire is frayed or damaged, leading to no signal being transmitted. Other potential issues may involve malfunctioning connectors between the turbocharger boost sensor and PCM that could cause intermittent or erroneous readings. Identifying the root cause of the malfunction is essential to restoring optimal engine function. When DTC P0235 is triggered, symptoms usually manifest as a noticeable decrease in engine performance, specifically a reduction in power due to improper air-fuel mixture management. The check engine light will likely illuminate, alerting the driver to an issue that warrants investigation. Additionally, unstable turbo boost levels may result, causing erratic engine behavior during acceleration. Drivers might also experience poor fuel efficiency as the engine struggles to operate under optimal conditions. All these symptoms indicate a problem that can affect both drivability and safety. To begin troubleshooting for DTC P0235, the first step involves turning the vehicle to the on mode without starting the engine. This enables the diagnostic system to enter a readiness state. Next, use the Honda Diagnostic System, HDS, to clear any present DTCs related to the turbocharger boost sensor. Once cleared, it's crucial to wait for at least 10 seconds before checking for any pending or confirmed DTCs, again with the HDS. If DTC P0235 reappears, it indicates that the failure is consistent and has been duplicated. If it does not, it suggests an intermittent problem may exist, prompting further investigation into potential wiring issues or loose connections, particularly at the sensor and PCM. The second troubleshooting step necessitates turning the vehicle off to prevent any electrical shorts. Disconnect the turbocharger boost sensor 3P connector to remove it from the circuit. After disconnecting, switch the vehicle back to the on mode while the sensor is disconnected. Using a multimeter, measure voltage at the identified test points between the sensor terminals. Specifically, measure from terminal number 1 to terminal number 3 of the turbocharger boost sensor 3P connector. Checking this voltage is crucial. If it reads approximately 5.0 volts, it indicates that the supply voltage to the sensor is present and aligns with expected parameters, leading to the next step. If not, further analysis of the wiring is needed. In this step, the shorted wire check for the VCC2 line is crucial. Begin by turning off the vehicle and then using the HDS to jump the SCS short circuit line, waiting over a minute to ensure the system resets. After this, disconnect the PCM connector E, which contains 80 terminals. Now, check for continuity between the designated terminals of the turbocharger boost sensor and body ground. Continuity at this stage indicates that there is a short in the VCC2 wire, which typically runs between the PCM and the turbocharger boost sensor. If continuity is present, this signals a need for repairing that short wire, while a lack thereof leads to checking for open circuits in the next step. Once you have confirmed no short is present in the VCC2 wire, the next troubleshooting step involves checking for an open wire situation. This is performed by testing continuity between the relevant points specified earlier. The procedure is conducted during the vehicle off lock mode, with the turbocharger boost sensor connector disconnected and the PCM connector also unplugged. By examining these specific terminals via a multimeter, we can verify if there's continuity through the VCC2 wire. If continuity exists, then the wire is intact and in working order, allowing you to proceed to the next troubleshooting step. If continuity fails, it indicates an open circuit requiring repair. Now we turn our attention to the SG2 line. Similar to previous checks, continuity must be evaluated, again while the vehicle is in off mode and with the necessary connectors disconnected. The objective is to determine if there is continuity between specific terminals of the turbocharger boost sensor and the PCM connectors, known as terminals number 1 on the sensor and number 78 on the PCM. Ensuring that the wire is not open is critical. If continuity is confirmed, the SG2 wire is functioning properly and intact, allowing the troubleshooting process to proceed. However, if there's no continuity, it suggests an open wire that must be repaired to restore the circuit. The 6th step focuses on the P3 wire line, requiring a similar approach as the VCC2 line shorted wire check. Start again by turning off the vehicle. Then jump the SCS line using the HDS and allow it to sit for over a minute. Disconnect the PCM connector E as previously done. Now, check for continuity between the turbocharger boost sensors terminal number 2 and body ground. Confirming continuity at this junction indicates a short in the P3 wire between the PCM and the turbocharger boost sensor. A confirmation of continuity necessitates repair of that wire, while a negative signal prompts further investigation in the next step. In this stage, we conduct an open wire assessment for the P3 line. This test should be performed with the vehicle off and ensuring that the turbocharger boost sensor connector and PCM connector are both disconnected. Check the continuity between terminal number 2 of the turbocharger boost sensor and terminal number 57 of the PCM. If continuity is established, it indicates the P3 wire is intact and functioning normally, leading to the last check. On the other hand, if continuity is lacking, it reveals an open circuit that must be repaired to ensure that the boost sensor can communicate effectively with the PCM. The final troubleshooting step comprises replacing or testing the turbocharger boost sensor itself. Begin by substituting a known good turbocharger boost sensor into the existing setup. After replacing, ensure to reconnect all associated connectors to maintain circuit integrity. Exit the SCS mode with the HDS and once again turn the vehicle to the on mode. Clear any DTC codes using the HDS and allow time for the system to reset, normally waiting for 10 seconds or more. Afterward, check for any pending or confirmed DTCs with HDS. If DTC P0235 remains absent, the sensor is functioning properly. If it reappears, consider replacing the original sensor or examining the PCM for issues before taking further action. After completing the repair, it's vital to perform a final verification to confirm that the problem has been successfully resolved. Begin this step by clearing the DTCs with the HDS to remove any error codes from memory. Following this, closely monitor the engine's performance to ensure it operates within expected parameters and remains stable during various driving conditions. This could involve both idle checks and acceleration assessments to observe for any returning symptoms. Ongoing vigilance is necessary to catch any potential recurrence early. A successful conclusion to this verification phase means that the repair was effective and the turbocharger boost sensor is now working correctly. Preventive maintenance is critical in avoiding potential issues related to DTC P0235 in the future. Regular visual inspections of the turbocharger boost sensor and wiring harness can help identify any physical damage or wear that could lead to sensor failure. Additionally, ensuring that all connectors are secure and free from corrosion can enhance the reliability of the electrical signals sent to and from the sensor. Consistent monitoring of engine performance can also help detect any early signs of related problems, allowing for proactive repairs before issues develop into more significant concerns. Taking these preventive steps can enhance the longevity and performance of the turbocharger boost system. In this presentation, we examine DTC P0235, which indicates a turbocharger boost sensor out of range, affecting engine performance significantly. Wiring problems, particularly within the VCC2 and P3 lines, are often the primary culprits leading to this fault code, emphasizing the importance of thorough checks along these circuits. The troubleshooting steps outlined provide a structured approach to identifying the underlying issues effectively, with each phase tailored for systematic diagnostics. Ensuring accurate repairs can restore optimal vehicle operation, reducing the likelihood of recurring symptoms. By understanding both the symptoms and the diagnostic processes, technicians can play an essential role in maintaining the health of Honda Civic models. Please like and subscribe to the channel. See you next time.